We're going to take a look at solving absolute value inequalities. That is much like solving absolute value equalities, except there's a few little differences, just like there were when you were doing regular linear inequalities and equalities. So, well, the same things hold true, that we have the negatives and the way that we get rid of the absolute value work the same as with the equations, and the extra work that you did when you were graphing these inequalities, it holds true the same. If you multiply or divide by a negative using that hashtag, then on both sides you end up having to flip that inequality. Okay. So in problem number one, same steps as equalities, make sure to get the absolute value by itself. Done. So now the absolute value is by itself, I need to get rid of the absolute value. That's what my next step is. So I get rid of it by going to the left side, so 2y minus 3, and then I've changed the answer to the negative. Well, because I changed that answer to a negative, I have to actually switch my inequality. And so this has got to be greater than negative 11. And so then on this side, I do 2y minus 3 is less than positive 11. I can leave that one the same. Okay? And both the 11 and the inequality stayed the same. Now, here's the kicker that gets a lot of people on this, is that this is an and equation. So this is less than and less than. Okay, so it's a less than equation. So this is an and equation when I go about trying to graph this. So I want to think through the answers that I get at the end to make sure that that they make sense. So now going through and solving though is really the same. I'm going to add 3 to both sides, add 3 to both sides. 2y greater than negative 8 divided by 2, and y is greater than negative 4. I did not divide by a negative, so I don't have to flip the inequality. Add 3 to both sides, I get 2y is less than 14, divide by 2, and y is less than 7. Okay, so this is an and equation. So now I want to think, are there numbers that are bigger than negative 4 and less than 7? And there certainly are. There are a ton of them. An infinite number, in fact. And so I got good answers there. Number 2, I want to get the absolute value by itself, so I have to multiply this by 2 to get rid of the fraction. So I multiply by 2 on both sides, and I get 3x minus 9, still in the absolute value, less than or equal to 2 times 12 is 24. Now my next step is to get the absolute value by itself, so I go and I split this. So on the left, I get 3x minus 9, switch the inequality because I'm going to switch the answer to negative. Then I get 3x minus 9 less than or equal to 24 for the second one. And now the absolute value is gone. So that was the reason that I split that. You need to know that the reason you split it is to get rid of the absolute value. Okay, so there's no more absolute value. Now I've got a less than equation again, so this is an and in between here. So I add 9 to both sides. 3x greater than or equal to negative 15 divided by 3 divided by 3. X is greater than or equal to negative 5. This is an and in between. Add 9, keep going on this side. So I get 3x less than or equal to 24 plus 9 is 33. Divide by 3. And x is less than or equal to 11. So now I want to know, are there numbers that are bigger than or equal to negative 5 and less than or equal to 11? And certainly there are lots of those numbers as well. So that's a good solution for us. Problem number 3, we need a little bit more space here, so let's get some space. And my first steps are to get the absolute value by itself. So I want to subtract 3 first. So subtract 3 from both sides. So I get 5, absolute value of 5n plus 7, absolute value greater than, just greater than, I guess, 15, 18 minus 3. Now, its absolute value is still not by itself, so I'm going to have to divide both sides by 5. So I get absolute value of 5n plus 7 greater than 15 divided by 5 is 3. And 5n plus 7 is still an absolute value. Now I've got the absolute value by itself. I want to split it. I'm going to split it that way and split it this way. So I get 5n plus 7. I'm going to the negative side, so that's to the left. I have to switch the inequality to a less than and change the answer to a negative 3. Negative 5n plus 7, leave it the same, and leave it the same. Go through and solve these. Subtract 7 from both sides. 5n less than negative 10 divided by 5. n is less than -2. Subtract 7 from both sides. 5n is greater than -4. Divide by 5, divide by 5. N is greater than -4/5. And that's perfectly fine. There's no big deal. It's just a fraction. It's okay. Settle down. Fractions are okay. Now, the word that goes in between, I want and or. This is a great or, so this is great or. Okay, great or. So great or means I'm going to put an or in between here. Now, the ors are a lot less restrictive when I look at these. I either need a number that's less than -2 or a number that's bigger than -4/5. Okay, because of the fact that it's an or, this is going to be just fine. There's not going to be any no solution with an or because it could fit in one or it could fit in the other one, and that's just fine. When you do the ands, though, you got to look out for those no solution ones. Okay, I could have a situation where it doesn't make sense to have a number that's smaller than 1 and bigger than 2. There are no numbers that are smaller than 1 and bigger than 2. Okay, so watch out for those ands as you're going along with these inequalities. Steps are still the same as equalities for solving these absolute values. The inequality rules are still the same. So if you switch it to a negative, then you have to flip the sign. If you multiply or divide by a negative, you have to flip the sign as well. All those things hold true as you're going through. Complete this worksheet. Take your time on it. Make sure you ask questions as you're going along.